To the True Energy training, we're going to be talking about power factoring, what power factoring is. Now, power factoring only gets generated when you've got an inductive load. Inductive load is anything with a north and south pole. Magnetic. Electromagnetic fields which can generate it has got a possible power factor incorrection that could be given attention to. If your volt would do this on your current, you'd have your amp do that. So that means it's a loss, but it's a loss to volt amp or kVA. I'll go into detail with that later. Now, if you have a channel, water channel, where you've got a little boat on it with no wind and you need to propel forward, you decide to use a horse to pull forward on the channel, and this horse cannot walk on water, obviously. If it did, it would have a one-to-one usage. The energy propelling forward is the energy that he's dragging behind. So he'll walk on the road next door, and that means it's going to use a additional amount of energy. That energy would be a 1 to whatever loss you've got. If you have got a 30% loss, it will be a 1270. Now, another example how to explain this is you've got the kilowatt. That is what you want to use, and there you can see the horse not walking on water to be able to get to the same level there. If we draw the line over there, that is the kilowatt. That is the additional, which is now the kVA. So that is your loss that you have. Now, a quick explanation on saying why does kilowatt it's not influenced if you do power factor correction. Many companies sell out on there saying you're going to be saving on kilowatt. Kilowatt equals volt times amp times power factor. kVA is simply the volt times amp. Now, if we're going to say volt being 200 volt times 1 amp times a power factor of, let's say, 0.8, so 20% loss, equals a 160 watt, or you could say a 0.16 kilowatt. If we're going to change that to a higher level, and let's say we make it a 1, that will also change. It will drop to a 0.8. Keep your volt the same, the volt. So what would happen? You'll still have 160 watt. So the conclusion is you cannot save kilowatt if you're correcting your power factor. Now, contrary to this, you're looking now saying the kVA. kVA is volt times amp. Take that same 200 times 1 amp and you get 200 VA. If we're going to go and drop that power factoring down, increase it there, we're dropping our amp, so the amp will be a 0.8 and you'll find a 160 VA. So unless you've been charged in kVA, it does not make sense to put power factor correction in. It just does not make sense. It does not make anything to your bottom line. You're going to pay exactly the same.